at this point, we now know how to create a database design and create a database design diagram, and hopefully define some of the data types and talk about the keys and things like that. So we're going to talk a little bit more about how to apply that design to a database, right? To actually create a database from that design. And there's a few prerequisites that we have to understand. So we're going to go through some of this stuff. We're going to talk about tables. Databases, tables, columns. We'll talk a little about the storage engines available to us in MariaDB, as well as MySQL. And we'll talk a little bit about indexes. It's important to understand indexes when you're making these design decisions and how they're going to affect the performance of our database. And then finally, how we can generate those scripts and we can apply those scripts to our database, which we're going to use in our labs in this unit. So first, let's talk about the database. So there's a couple commands we have. And by the way, when we say databases, right? So here it says show database. That's a command. When you run that command, show databases, at the MySQL command or the MariaDB command prompt, it's going to output all the databases you have in your database, right? Another word for that is schemas. So you could type show schemas and it'll show the databases, or you can call them the schemas, right? So a lot of these commands, when we talk about databases, you can use the term database or schema sort of interchangeably, right? So in this example, if you type show database, remember to always put the semicolon at the end. The semicolon is what ends the command when you're typing a command in the database. So always put that semicolon at the end. If you're doing a multi-line command, you wouldn't do the semicolon until you get to the last line. You're going to see that here in a few slides. If you don't have a database, right? So when you first installed MariaDB, you didn't have a database, you created one. Now, if you're following along with these videos, you probably created it using either SQL Yog or MySQL Workbench. So it's a GUI, you right-clicked, and then you created your database. But you could also do it right from the command prompt in MariaDB. And for the most part, I'm going to try to show you a couple different ways to do a lot of this stuff. So, in the lab, we're going to probably use some things. I'll use the Workbench or SQL Yog. I'll probably stick to Workbench because I know that everyone will have that since it works in both Mac or in Windows. But you can also use the command line to do that too, and we'll show that as well, a lot of these different commands. So if you type create database in this example eShop, this is from the Essentials of MariaDB book that's part of this course. When you run that command, it'll create your database, and then you can type show databases again, and it'll show that your database has been created. In this case, we have that database eShop, right? So we have 4 databases or 4 schemas in this database engine, or in this instance of MariaDB. Once you create a database, you could also drop it. Quick warning though, is if you drop a database, it's going to remove everything that's in that database. So you have to be careful with the drop command. So if we drop database test, then I show my databases. Test is no longer in my list because we dropped it. And that's the database that, I was creating a test database in my last video before this one in our lab video. So as an example, you can create your database, you can show the databases you have, and you can drop a database when you're done with it. And again, you can use the term schema instead, right? So schema is interchangeable with the term database in MariaDB and MySQL. So if once we create a database, we have to type use to use that database. You'll notice here there's no semicolon at the end. This is one of those commands where you actually don't need to put the semicolon. So if you just type use and then the name of the database that you want to use, it'll just, as soon as you hit enter without having the semicolon, it'll put you right in that database. Now, of course, if that database doesn't exist, you're going to get an error. It's going to say, I don't know what that database is. But if it does exist, you'll see in the second part of the lines here that you're connected to that database, and you'll see the name of that database in the prompt, right? So if you look at my prompt, it says MariaDB, and then it's got the name of the database inside the brackets. It's a good idea when you're working with the database engine to always look back at those brackets to make sure you're in the right database. I've worked with people that thought they were in the test database, but they were actually in production and they were messing around with tables, or they accidentally deleted an entire table or dropped an entire table, which is disastrous, right, in the production database. Especially if you don't have transaction logging or anything, which we're going to talk about later on in this series of courses. So again, make sure you know what database you're in, and also, especially when you're doing the labs, you might be working with some of these commands and you'll run a command and it'll say that table's not found, and you'll think, well, that's strange. I know I've got that table. But then you'll look and realize, oh, I'm in the wrong database. I forgot to type use whatever the database name is. And you'll get in the hang of typing that in as you use the database engine. So let's skip ahead here and talk about tables. So tables have to get created just like databases, right? So we create our database, then we create our table. Again, In the previous lab, when you install MariaDB, I think I walked you through doing this from MySQL Workbench, but we can also do this from the command prompt. And both textbooks that I'm using in this course, Modern Databases by Jeff Hoffer and also MariaDB Essentials, both of them walk you through some of the syntax. Now, the Modern Database book is more generic. It's going to walk you through some of the SQL 99 syntax, the ANSI SQL syntax, whereas the MariaDB book is specific for MariaDB. And you can kind of see what the differences are. So there are some things that you won't be able to do in MariaDB that might be in the standard, and there will be things in the MariaDB book that are not really clearly defined in the SQL standard, which our book is based off of. But the basics are there, right? The syntax is there. Once you get the hang of the syntax, I think you can pretty much apply it to any database engine. So if I wanted to create a table called catalog, and you can tell the book was written in Europe, right? Because it's the European spelling of catalog, right? The UK spelling. But if I wanted to create the database, first I type create table and then the name of the table I want to create. In this case, it's catalog. Well, maybe that's a good thing it's spelled that way. We don't get it confused with the reserved word catalog that has different meaning in databases. So that first line, so when inside the parentheses is going to be your list of columns, and also any references to indexes and primary keys. So that's going to be inside those parentheses. And then we'll put other stuff outside the parentheses, which you'll see here in just a minute. So in this particular example, we have a column named ID. So that's the first thing you see. The column name is ID. The data type is integer, and it's an unsigned integer, right? So it's a special type of integer. It's not null. So not null means that the value of that column can never be null. We'll talk more about nulls here in a few minutes when we get to columns. So it can't be null. And then finally, the last keyword is telling us that that column is going to auto increment, which means that it's not only an integer, but whenever a value is inserted, the default value is going to be whatever the next sequence is for that integer. And that's a nice feature of MariaDB that it allows you to very easily auto increment ID fields like this. For example, Oracle doesn't really have that capability, at least in most of the versions I've used, although they may have changed it by now. But you used to have to write triggers to do that, to create an automatic sequence when you're inserting records. And it's kind of a convenient way of setting IDs. And we're going to do that in our lab. We're going to use some, when we create our little database to play with, we're going to create some auto incrementing IDs for our primary keys. All right, so now you'll notice here that there's nothing that says that's the primary key. We do that later. So I'll show you that syntax in just a moment. And then you would keep going, adding your additional columns, right? So I've got a name column. It's got a data type of varchar, maximum length of 50, and it can't be null. Then I have the price, which has a data type of decimal. It's 6 is the length with a precision of up to 2 decimal places. And that's allowed to be null, right? So when we just put null, that means it's okay if it's null. The quantity is a small int. So integer, I think, is 8-bit, and a small int is 4-bit. So it's not null. And the default value for that column is going to be 0, which means if somebody doesn't put a quantity in when they insert a record, the default is going to be 0. So it can't be null. And if somebody tries to insert a null, it's just going to set it to 0 instead. And then we have a description, which is a text field. So it's just another data type, and it can't be null. So a couple additional fields there. As I said earlier, we need to have a primary key. Typically, we want to make sure we have a primary key on all of our tables. So after we put all of our column names in, we would add what the primary key is. So in this case, the primary key is that ID field, and we put that in parenthetically. Once we're done, right, so we've defined that schema for the database, then you can put additional options outside the parentheses. One thing that's interesting in MySQL is you have to indicate which database engine you want to use. There are several different ones, different storage engines, and I'm going to talk about those in a little bit. In this example, we're going to use NODB, which is also typically the default for MariaDB. It's sort of the most reliable, older storage engine. It's been around for a long time. With MySQL, and of course, followed through to MariaDB. But if you didn't define NODB, it would use the default that's set up in the database engine in MySQL or MariaDB, which typically is NODB by default, but you could change that to one of the other storage engines if you wanted to. You can also add a comment. And just to add to this, you can actually have a comment on any of your columns as well. So both the column can have a comment as well as the table itself. So the comment really serves no purpose other than documentation as to what this table is. I like to put comments on most of my tables and columns so that I know what they are, and they can be used by other people to figure out what they are. In fact, you can even use them in applications. So, you can expose that information to users if you wanted to through applications, if it made sense to do that. So comments are definitely good. It gives you a nice way of documenting things within the database engine. All right, so that's how we create a table. That's the syntax. Um, Once you create a table, use the show tables command when you're in a database, and it will list all the tables you have in your database. Right? In this case, we only have one. We just, we typed use eShop. We got into the eShop database. We ran that create statement that you saw on the previous slide, and then created our catalog table. And now when we type show tables, we can see that table. And if there were other tables, we would see them all listed here. So it's a nice way to see what tables you have. And again, you could use MySQL Workbench to do this too, right? It'll connect to the database engine, and it will give you that schema for the database if you like. You could also rename the table. So if I typed rename table catalog to product, it's going to change it from catalog to product for the name. So I hit enter, and it would tell me that it's completed, and it renamed it. If you're done with a table, you don't need it anymore. Use the drop command to drop a table. So you type drop table and then the name of the table, and that's it. It'll be dropped. And then all of that data is gone, right? All the data that was in that table will be gone. In fact, if you try to type some of these commands like drop table or drop database from within MySQL Workbench, depending on how you have it configured, it'll either prompt you, right? So after you hit the button to try to run the command, it'll either prompt you to say, are you sure you want to drop this table? Or it'll tell you you're not allowed to because you have it set up in safe mode. So there's a little button you can hit that says, safe mode, so you can't accidentally drop tables and databases and things. Doing a drop is generally not reversible, so you have to restore from a backup if you accidentally drop something. And we'll talk about how to do backups in the next course. So in Info 366, we talk about backups, high availability, business continuity, and things like that with databases and how we accomplish that. So before you saw me creating columns with different data types, there are string data types, numeric data types, and other data types, and we'll talk about all of these. I talked about these in the presentation in physical database design, but these are the data types that are specific for MariaDB. So these are the ones that we're allowed to use in MariaDB. Not all of the ones that I showed you in that previous lecture can be used in MariaDB or MySQL, but I wanted to expose you to all the different ones you might find. Other database engines have different types. And don't forget that I showed you the difference between a variable character field and a character field, right? So you can see here the first two data types are char and varchar. Note that the char is not dynamic, whereas varchar is the dynamic version of char. So they're really kind of the same, but one is dynamic and the other one isn't. Also take a look at the maximum size. The maximum size for a varchar is 65,535 bytes. That's 32-bit, right? So that's 32 bits long, that number, right? So it's not randomly 65,535. Also var binary, right? That one's also 65,535. If you created a column and you made its maximum, let's say you created a char column and its maximum allowable size is 255, all of the columns combined cannot be more than 65,535. So a single row in MySQL or MariaDB is limited to 65,535 bytes. You cannot have any more than that. So if it's a non-dynamic, if it's not a dynamic field, and there's some other ones we're going to see here in a few minutes. If it's not dynamic, then the database engine is going to add up all of the maximum sizes, that you set for those columns, right? Because you set these, when you create a char data type, you put in the parentheses, is it 50, 100, or 255 if you want to go to the max. If they're too large, it will probably not let you create the table. I think I've done that a few times where when it adds up all the sizes, it comes to something larger than that. Now with varchar, in theory, you could create 5 columns that are varchar with 65,000 as the length, right? You could do that if you wanted to, and the database engine will let you do that. But if you ever try to insert records that make the aggregate size of that row more than 65,535, it's going to fail. The insert will give you an error. But if you insert 4 values or 5 values across these 5 columns that are small enough that they all fit within that data size, it'll work fine, even though the columns were declared longer than the maximum allowable size in MySQL or MariaDB. So you've got a bunch of other ones here, right? We've got text, right? So text has a maximum size of 216 bytes, but it's variable, right? medium text and long text, tiny blob, a blob, medium blob, right? So a couple different ones. Um, and again, these are all string data types. They're all intended for character data. So let's take a look at another data type. This is numeric data types. So we have tinyInt, which is only 1 bit, right? Some people call that a Boolean, right? So if you're in Microsoft SQL Server, I think it's called a Boolean. I think in Oracle it might be called Boolean as well, but it's tinyInt in Maria and MySQL. Then you have a small int, which is 2 bytes, and then a medium int, which is 3 bytes, and then integer, which is 4 bytes, right? So the largest number that you could use in a 1 byte that you could use with 1 byte. Remember, 1 byte is 8 bits, so it's 255. And then as we go up, they get bigger and bigger and bigger, right? So 4 bytes, I think, is 65,535, right? That's going to be an integer. That's a pretty decent sized number. And then a big int is, I think, somewhere in the billions, right? So it's going to be a huge number. I think it's 2 billion something. I could be wrong, but it's a pretty large number. So these are the different numeric data types. There's other ones too, right? So there's also decimal, where you can declare the precision of a decimal. So there's a few other ones that are not listed here that you saw previously in some of the other slides. This is certainly not a full list of these. You have temporal data types. These are time-based, right? So you have a timestamp, which is the number of seconds that have elapsed since 1970 on June or January 1st. So it can store a pretty granular time based on seconds. And then you have a date time, which is, of course, a little bit bigger in bytes, right? So they could go down to the millisecond. I think actually further than the millisecond. Just the date, which would be, just a calendar date, just the time, and then just the year, right? A year is pretty small. You only need 1 byte to store a year because it's, they're not large numbers typically. So those are some temporal data types. There is also special data type in MySQL, MariaDB, enum, and set. So what an enum is, it's a special data type which defines a list of values that are valid for the columns. You're going to see in our example where using enum might actually make sense for some of our tables. We're not going to do it in this particular exercise because it would be a little bit more work to do that, and I want to try to keep things as simple as I can for what we're going to do. But you could, for example, let's say you have a column where the possible values are yes or no. So you could define that here's my column and the allowed values are yes or no, and that's it. And you have to use one of those values. They are typically always strings, right? So whatever that enumerated set of values are, they have to be at their heart, they have to be character strings. And when you're inserting, you can you do an insert statement works just like it normally does, right? So we haven't really talked about insert, update, and delete yet. We're going to talk about that. We'll revisit that a little bit later on in the course. And again, it's going to be really just a review because hopefully you've learned that already in the follow-on to this course. But when you do that insert statement, usually you just have the string surrounded by single quotes. You do the exact same thing here. It's just that if the value inside those single quotes is not one of the enumerated values, it's not going to let you insert it. But you can also reference it by its ordinal position, meaning that if you have a whole bunch of values that are enumerated, if you want the third value, you can just put 3 instead of the string for that matches that value. So again, you could use the ordinal position, which is a little different than a normal insert statement. So it looks like you're inserting an integer, but really you're inserting that specific value that's in that ordinal position in the enumerated list. A set is really the same thing as enum, except you can have multiple values. So you have a list of values that are allowed in the column, but instead of just having one value in that column, you can have multiple values apply to that column. So it lets you have sort of a many-to-one relationship within that column from an enumerated list of acceptable values. So some interesting places you can use that. And again, you may see some examples in our exercise where you could have used that. And just to show you what this looks like, this is from your textbook. I'm sorry, not the textbook, from the MariaDB introduction book, The Essentials of MariaDB. So here we create a table, right? This looks just like any other create table statement, right? Except when we declare the column color, it's an enum, right? So we add that enum a keyword and parenthetically the list of the different colors that you're allowed to pick. So in this case, When inserting a value into color, it can be white, black, green, or blue, and that's it. If you don't put a value, it's going to make it white because the default value is going to be white. That's it. So it's a really simple table. It's got one column, 4 possible values you can have for that column. So I hit enter because I've got the semicolon at the end. It's going to run that command. It's going to create the table. Now when I go to do an insert, right? So I'm going to insert into that table a color, and the value is going to be 1. So it's going to be the ordinal position. Well, the color in position 1 is white. So if I run that, it should have white in the first row. I could also just reference it by its actual color name, right? So I could just put black, for example, as my value, and that would work as well. And then if I select all the columns after I run these cups, so I created the table, ran 2 insert statements. Now we look at the contents of that table, and it should have white and black, right? The first row is white because we inserted number 1, which is the ordinal position of white. The second time we did explicitly, we inserted black. Okay, so that's how we use enum. And again, set is going to be very similar, only going to have multiple values in that column. So, which are comma separated, by the way, when you're doing an insert statement. Next, I want to talk about some other special values or special character or special attributes about columns. One is null. What exactly is null? Null means nothing, right? Don't get that confused with 0 or blank, like a blank string. It is literally nothing. It's emptiness, right? There's nothing there. So null means that there is nothing there. It's a little bit different than 0 or blank. The thing about nulls is sometimes nulls will ruin your day. If you're doing things like aggregation, if you're adding the values, or you're trying to get a sum or an average with a group function, which we're going to talk about at some point. All that stuff is gonna break if you have null. So you have to catch that. You have to say where the column is not null, right? So you take those out of the set before you try to do any kind of math operations. The thing about SQL is if there's nothing, anytime you do any kind of aggregation with nothing, it makes the entire set nothing when you do the aggregation. So you're going to get a null back. So you're going to say, give me the sum of the cost of all the products on this invoice. Well, if one of the products has a cost of null, meaning that there's nothing there, it's going to make the sum null, even though it doesn't skip it, and pretend that it's a 0. It treats it as null and says, oh, I can't do this mathematical operation, so it returns null. A default value, which you saw a couple times now, is every column can have a default value. This is one way that we can deal with nulls, right? So we can say, well, I don't want to allow nulls in this column. So if somebody does try to insert a null, instead of returning an error, instead it'll just put some default value. For example, when I talked about the price of a product on an invoice, you could make it not null, but then make the default 0. So if somebody does not insert a value for the price, it'll just assume that it's 0 and put 0, which is probably what we really want, right? We just want to assume that it's 0 if somebody failed to insert a value. Now, how could you fail to insert a value? Let's say you've got 6 columns in your table, and you write an insert statement that only inserts 5 of those columns. The 6th one is not included in that insert. The database engine will make that a null value, right? So it'll try to make it null. So if it's set to not null, that statement will fail unless you have a default value defined, in which case the statement will work and it'll simply assign it its default value. The other thing I need to talk about, really we could talk about this anywhere, is character sets. An example of a character set is UTF-8, which is the default character set in MySQL and MariaDB. Basically, a character set is a mapping of bytes to characters, right? When you think about it, all the characters we have in our database is nothing more than a collection of ones and zeros, right? When you really break it down, it's at the lowest level, it's just binary data. What makes that binary data meaningful is things like character sets that provide a mapping. So we can treat data as numbers, right? In which case binary is inherently obvious what it is, right? Because it's just numbers. But if it's not a number, our computers only understand numbers, so we have to have some mapping of numbers to characters, right? So we say, the number, 0C is always the space key on your keyboard, and 0D might be the carriage return, and so forth. I don't really know what these are off the top of my head, but that's a character mapping, right? It just so happens UTF-8 is really just ASCII, right? So one of the first character map sets that was defined, fully defined character sets, was ASCII. It was probably the first standard all the way back in probably the 50s or 60s or something. and it only supported, so it's called UTF-8 because it's only 8-bit, right? So it only supports 255 different characters. If you have more characters than that, UTF-8 is not going to work for you. So additional character sets were created later on, and you'll see those in some of the examples. I might use like Latin something, or some other character set which includes all the English characters that we might be used to, in addition to a bunch of other characters that can be used by other languages because they use more than 8 bits. So you have a lot more options. And don't forget, our alphabet in English is only 25, letters, right, or 26 letters, um, but you also you have to do both uppercase and lowercase, right? The computer doesn't know the difference, right? So so now we're over 50 characters, and then you have all the punctuation and numbers and various symbols like spaces and carriage returns and line feeds and and so forth and so on. So when you put all that stuff together, you're almost up to 255 characters, even with relatively few characters in our language. But then you get to more complicated languages with larger alphabets, and you can see how you can very quickly run out of space in the character set mapping. So we've got lots of different character sets that we can use. If you use the wrong one, then data is going to be stored a little different than you thought, right? So it's something to be aware of. We don't usually see that when we're dealing with databases in English. All these database engines are kind of defaulted to English anyway, so you'll run into this problem, into these concerns, generally if you're working with foreign databases. All right, so like I said, we can use other character sets. Now, I alluded to this earlier about storage engines. There are different storage engines. If you recall, when I did that create table statement that we stole from the MariaDB, the Essentials of MariaDB textbook, they included engine equals NODB. But we could have done a different engine, right? There's I think probably 5 database engines that we can use in MariaDB as I'm recording this. NODB is the one that most of us are familiar with. It's the default, right? It's generally considered the fastest and most reliable. Um, in the majority of cases, it works. It's ACID compliant. Um, you may have learned about some of this stuff in your other database classes, but basically, it's the most common database, most common storage engine. The thing about NODB, though, that's important to know, we talk about foreign keys and we talk about primary keys and things like that. NODB has one major drawback in that it does not support referential integrity natively. So that means that NODB will not, let's say you create something, a column, and it has a reference. It's a foreign key that references the primary key in another table. That's great. It's a good note to have, right? So you look at the schema and it'll tell you that it's a foreign key and that it references another table, but it does not enforce that relationship. And a lot of database engines do that for you. So when you look at things like Oracle or Microsoft SQL Server, they have that baked into all of their database engines, right? It's really only one engine that each of those have. They don't have these different options, but that's included, right? So if you declare a foreign key and you include that referential integrity in your schema, the database engine ensures that it works, right? It makes sure that it's there. NODB will not do that. So it'll let you break those rules. It doesn't really enforce those. However, MyISAM does do that. So if you use the MyISAM engine, it will enforce the referential integrity. So it's a little bit better than NODB in that sense, but it doesn't have the performance that NODB has, and it's kind of obvious if you think about it. If you're not doing any of that extra work of checking referential integrity, and with the same resources, it's going to be a little bit faster, right? For sure, and it may even be more reliable because it's simpler, right? Sometimes simple makes things a little bit more reliable. But MyISAM is a good option if you need that referential integrity. And again, it's another option. Area is another one. This is a relatively newer storage engine. I have never used Area. It was apparently developed as a crash-safe replacement for MyISAM, so that sounds pretty promising for MariaDB. But again, I've never actually tried it, so I can't really speak to Area, how well it works, or if it really is as good as they say in the Essentials of MariaDB textbook. But certainly something we could try, right? If it's, I think we'd have to install it in our MariaDB. It may not be included by default, um, but certainly something that we could try in this class if you're feeling adventurous and you want to give it a try. But I'm not going to require it in this exercise in this class. The other type is memory. So that now memory is really, really fast because this runs the entire database in memory. But when you shut down the database engine, anything in memory is going to be lost, right? So if you restart the service, everything that you've done is gone, right? It's not stored persistently on disk. It doesn't manage any of that. So anything you do when you restart, it's going to be lost. So it's good for ephemeral uses, right? If you have temporary data, or you're working with something that it doesn't have to keep it stored long term, right? And there are certainly some applications for memory only databases, right? Um, something like a network device. A lot of times, the configuration might be very simple, but once it's up and running, it'll run everything in memory. If it shuts down, that's okay. It'll just rebuild, the ARP tables, for example, right? Who cares if that gets wiped out? It just rebuilds it the next time it starts back up, right? And then finally, there's the black hole database engine, and basically that is a black hole. Anything you store there will never come back. So it's what we used to call the bit bucket back in the old days. So the bit bucket is a place that you store data that you want it gone. So that's what the black hole is. I've never used the black hole storage engine in MariaDB. I'm not entirely sure why you would use it exactly, but it's there, I guess, if you want to use it for something. So now, like I said before, I wanted to talk about indexes very briefly. I talked about indexes before, but it's something that's important to be aware of in how it affects the. So database designers have to think about indexes because they're thinking about the usability of the database and the experience for the user. And as database administrators, sometimes we have to understand indexes because there's this sort of back and forth with how much we actually need indexes, or do we have too many indexes? And I'll talk a little bit about that. But as far as exactly what an index is, so when you think about an index, I like to explain it like a card catalog in the library. And I know a lot of folks are probably not, probably don't remember a card catalog. So I'll explain what they are. Back in the old days, before we had computers in every library, and I know that seems like ages ago, but it, wasn't that long ago. It was my childhood. We didn't have computers. We still had card catalogs in the library at the local branch. Um, so if you wanted to look up a book, there's many different attributes that could describe a book, right? You could have things like the title and the author and different subjects and so forth. So in most libraries, they would take any book that they needed to index in the card catalog, right? So it's an index of all the books in the library. So you had this big all these little drawers with cards on them, right? Because we didn't have computers, so you had to look them up on cards. So there would be 5 cards for every book. There would be 1 card for the title. Another card would have the author's name, and then 3 other cards would have a subject. You could pick 3 major subjects for a book. For example, the Essentials of MariaDB book might be filed under computer science for one subject, management information systems for another subject, and databases for the other subject, right? So somebody kind of makes the decision. Usually the authors or the publishers would do that, right? So the publishers, when they send the books to the library, they'd say, here are the 3 subjects that you should file this book under, because they know better than anyone, right, what their books are. So when you go to the library, you would, let's say you're looking for books about elephants. You would open up the card catalog and go to E and then find elephants, and you would see all the cards that have books about elephants. So you would find maybe there'd be 30 or 40 cards that cover the subject of elephants, and you can look through, and they would have a little description of each one of those books, as well as the address as to where to go to find that book on the actual shelf, right? So it would give you the location to go and find that book on the shelf. Our databases work almost the same way with indexes. If you've got a table with millions of records, it's just like a library that has millions of books, right? There's no way we can look through. If we're looking for a specific book, we're not going to be able to find it on the shelf in the library unless there's some index that tells us where it is. So we go to the card catalog to find that specific book, just like in our database. A lot of times when we're searching for things in our database, we're not searching the table, right? Because then we got to scan the entire table. Instead, we're going to the index, which has just the key fields. We pick a couple key fields, just like the librarians had to pick from those 5 fields, right? They said all we have is title, author, subject, 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 right? Somebody at some point made that decision that that's what we're going to index our books on. Just like a DBA has to make that decision about the data in our database. Okay, here's a table that has all this information in it. What would somebody be most likely to search for in most instances? And that's what we want to use for an index. Now, does that mean that if you don't index something, it's not going to work? No, it'll still work. It just takes a long time, right? Just like going to the library. If you have all day, as a lot of us did this when we were kids, we go to the library, you've got some time to kill, back before we had, Nintendo and all of our, video games and smartphones, right? When things were a little simpler, you could go to the library for an afternoon and, maybe you didn't feel like looking through the card case. You just know you want a book about elephants. You just walk around and, you know, you just look for books that you're interested in, right? You just browse, right? But it takes a long time. So you can do that in the database too. You just tell the database, I'm looking for this record. It'll just browse all the records it has in that database and try to find it for you. But again, it takes a little longer. Now, and of course, in the database world, it's a computer doing this. So computers are really good at looking through records really fast, right? But even that, with that said, if you have millions and millions of records and hundreds of thousands of people searching those records all the time, there's resources that are involved. It can take a considerable amount of time to find records. So again, we have to try to weigh, whether or not we need these indexes. So why wouldn't we just index everything, right? If we have too few indexes, the database engine is going to take a long time to find all those records. As I said before, it's going to do these full table scans, which are very time consuming. So you might be tempted to say, well, let me err on the side of caution and just create a whole bunch of indexes. But think about those librarians, right? I mean, the librarians could have chosen 10 subjects instead of just 3 for every book. But that would mean that you have to now maintain 12 cards for every book instead of just 5, which is a lot of cards, right? So just like our librarian has to manage those cards in the card catalog, our database engine has to manage all of these indexes, right? So every time somebody inserts a new record, the index has to be managed. It has to be updated. When somebody deletes a record, we have to change the index. If you update records and it changes an index value, we have to go and update in our index. We have to reorder them so they're in the right order, right? Sometimes I explain it like my mother with her telephone book when I was a kid. Before we could save numbers in our phones, my mother had this telephone book that she would write all the phone numbers of all of our friends. But it had like a page for each friend's name. But if she ran out of space on that page, she would find another page to put their name on, right? So you'd say, Mom, I can't find Joey's phone number in the book. His last name is White, and you're looking under W, and she would say, oh no, it's under J for Johnny. Or, gosh, I can't find him under J either. And she'd say, oh no, it's under S for Sassafras. That's the street that he lives on, right? Or it's under B for Barbara, which is his mother's name, right? It could be completely random. So you'd have to end up paging through the whole book anyway. Same thing happens with our indexes, right? In the database engine is going to add stuff to that index, knowing that, okay, I don't have time to build the index now. I'll just tack it on the end. And I know every time I check the index to also check the things at the end just in case. And then eventually all that stuff ends up being bigger than the index list itself if it's not maintaining the indexes. So lots of things to worry about there. So choosing appropriate indexes and weighing these different options is one of the important design decisions that have to be made between the DBA and the database developers. So it's really important to understand how they work. Now, finally, I'm just going to talk very briefly about generating statements, right? So if you already have let's say you already have a table created and you want to see what that create statement looks like. If you do show create table and then the name of that table, it's going to output for you what that create statement would look like to create that table. So it's going to show you the schema for that table. You can see here it even has the notes at the end that it's NODB, that the default character set is UTF-8. It's got the comment for the table. You can actually see there is an example of a comment on a column, right? So this is outputting for you the script that you would need to go and create that table on some other database if you wanted to. Or if you drop that table and you want to recreate it, you could use this script. Now, let's say you ran this command a bunch of times and you created a list of SQL commands that you want to run against the database. If you when you run the MySQL command, so you put -u and then your username -p, your password. And then if you put that less than symbol, right, and then the path to a file that contains SQL commands, it's going to run those SQL commands. So instead of logging you into the database, it's just going to take whatever's in that file, run all those commands, and return you back to the command prompt without even being in the database. So that's how you can run a SQL script. It's a script of commands if you wanted to. You can also go the other way around. The MySQL dump utility, when you run that, and again, this is from the command line, so you're not in MySQL when you run this. You're going to run this from the command line in Linux if it's on Linux, and of course in Windows if your database engine is installed on Windows, which we didn't do in this class. But when you run MySQL dump, again, it's one of the utilities that's included with MariaDB. Pass in the username and password just like MySQL command, but you put the name of the database, a greater than sign, and the name of the script file that you want to generate. Now, if you run that command, if you add the -- no data, which is an option, right? So just like any other command, it's got options. If you add that option, it is not going to generate the insert statements for this database in the SQL script. But if you leave that off, it's not only going to create give you all this create statements to create all of your tables, just like it is in the database as it sits in MariaDB. It's also going to generate insert statements, so it can insert all of that data for you into that new database. So it's going to do both. If you don't put that statement on it. So if you have a really big database, this is going to take a long time to run, right? You're going to get this huge database file if you've got a really big database. So sometimes we only want to see the schema, right? Because we're going to maybe just build the schema on another database. You might see us do that in the next quarter in 366, Info 366, where we talk about replication and database backups, and we'll talk about distributed databases and things like that. So there are certainly lots of times where you want to build a database schema on a different system. Or if it's an application you're building, right? They might give you a SQL script that you have to run, or you might want to create one. Maybe you spent all this time creating a test database in development, and now you're ready to roll it to production. It's just an easy way to take that whole schema and save it into a file that you can then run to import into another server somewhere. And again, Workbench and SQL Yoke, those tools have utilities to do this as well, and we'll probably play with those in our, in our assignment. Okay, so one thing I didn't talk about is you can change tables, you can change columns. Once you create a table, let's say you wanted to add a new column to a table, you use alter table, the name of the table, the add and column keywords. The if not exists means that it's only going to add the column if it doesn't already exist. If you look in the Essentials of MariaDB textbook at the very end of this chapter, I think it's chapter 2. At the very end of chapter 2, it gives you a couple more examples of this, and it also shows you the different syntax for if not exists. There's a couple other ones. So there's if exists, if not exists. You could also modify a column that already exists, right? So you could say, if you have column 2, then modify it. Maybe you want a different length, right? So what that will do is, and by the way, if you did not have the if exists there and that column didn't exist, this statement would generate an error. But because we have if exists, if the column does not exist, it's just going to do nothing. But if the column does exist, it'll modify it. In either case, it's not going to throw an error. Just like the top one, if that column was already there and we tried to add something, it's going to throw an error. But in this case, it's only going to run if the column isn't already there. So it makes sense to do that. And then this example, this is modifying a table to get rid of an index. So you can add indexes, you can remove indexes, you can change the primary key if you want to. Sometimes it won't let you do that if it's, let's say you're changing the primary key to a different column and it's not unique. The database engine is not going to let you change it, right? So you can pretty much change anything you want after a database is running. It's not locked in stone. Although generally it's better to do a design that doesn't have to be modified very often, because it certainly can be challenging with larger databases that applications are using and things like that with other design considerations. So that's it for this week's discussion. Make sure you watch the videos on the assignment as well, the practical assignments.